All right, guys, we're going to go ahead and get started here. And this month for the workshop, we're going to be going a little bit into Godot 4 and networking, specifically through the C# implementation, because we have traditionally been a Unity shop for all of our existence. C# is what I know and what I work with. Um, in Well, I guess to start with, you need to start with downloading the .NET version of the Godot engine. This is separate from the regular version of Godot, but everything still applies. Still use PD script when using this, but this also gives you access into C# .NET world, which you can get into here. This actually might be incredibly short because there's actually not a whole lot going on with networking in Godot. Um, Only a couple of specific networking nodes, and how you actually set up and connect to each other is relatively simple. But anyways, after you have downloaded Godot somewhere, you can open it up just like normal, just like any other project here. And when you open up a project here, um, basically all you need is a couple of multiplayer specific nodes that you might want to have. One of them is a multiplayer spawner. The other, I don't know, down to would be a multiplayer synchronizer. I do not add it to add to the child node, the multiplayer synchronizer. The multiplayer spawner is going to be responsible for replicating um, its child nodes, and the multiplayer synchronizer is going to be synchronizing your various variables you can set up here. There we go. Here in the docs, we can go through a little bit of the high-level multiplayer. So here in the have networking. There's not an incredible amount here. But this basically goes through the high level versus the low level API. The high level API we'll look at a little bit. It is a multiplayer singleton that is said it doesn't do a whole lot, but this is how you will set up your multiplayer peers, which are your clients. There's a number of different transport options you could use. There is the eNet multiplayer, which is your basic UDP transport layer. You've got a WebRTC multiplayer peer, which will connect your clients through the WebRTC protocol. And you also have WebSockets. So if you are hosting your game on HIO or something like that, you can use the WebSocket here. We'll be using ENNet for most of everything here, but the other multiplayer peers work just fine. By default, it kind of works on LAN only. If you want to use Relay across the internet, there's other packages and assets you can use. I'll go over a little bit on a couple that I found that worked really well for your Relay connection and for creating lobbies. So like I said, mostly time by default, you'll be connecting to your local area network. You can set up like port forwarding on your router to connect if you're like self-hosting a server. Or if you're hosting your server out on Amazon, you can just connect directly to that IP address. The differences between GDScript and C# is not a whole lot, actually. I thought this would have been a bigger deal, but basically it just comes down to translating the GDScript into C#. And they did a pretty good job of keeping the syntax basically the same. In GDScript, everything is kind of lowercase, Pascal case, I think this is what this is called, with the underscores, and with C#, uppercase for your singletons and whatnot, and then camel case for your functions. Really the big difference. So when you are first initializing it, the high-level multiplayer API object, this is kind of initialized for you. You can either get it from the singleton, or you can grab it from your scene tree and have multiple scene trees with multiple different multiplayer instances. So if you're on your server side, if you wanted to connect to ENNet and to WebRTC, you're doing some cross-platform shenanigans, you can do it that way. You would just need to have multiple different scene trees for that. Here we're creating our peer. In GDScript, you'll just do ENNet multiplayer peer.new, and then you create your client with your IP address and port, and then you assign that to your multiplayer peer. For the server, it's about the same, but you just use create server, and you give it the port that it's listening to and the maximum number of clients. And on the C# side is basically identical. And that is basically it. When you want to close your connection, you just set your multiplayer peer to null. Or in GDScript, this is, I guess, is a bigger difference. You have a offline multiplayer peer. You would just assign it to your multiplayer peer. There are some exceptions for Android, and I think WebRTC does not port to C#. I want to say that was a thing that I remember reading. Scripting. Differences. Yeah, Android support is currently experimental. I think folks have gotten it to work. I don't remember there being much issues with that. But also projects with C#, cannot be exported to the web platform. So if you're using C#, you might want to downgrade to Godot 3 if you plan on launching on the web. That's a pretty big gotcha there. Okay. And basically, you are left with RPCs to communicate with. Um, there aren't really network variables outside of the multiplayer synchronizer node that we looked at a little bit. Everything is going to that you send across the network will most likely be going through RPCs. And there's only a few gotchas here with sending data. And I was in a second here. But to create an RPC, you just have your function here with, in GD script, it's at RPC. And in C#, it's an RPC attribute. That's for your basic RPC. There are parameters that you can set here for your authority mode. So you can have it so only the authority of that node can call it remotely. And you can also just have it so any peer can call this RPC remote. The authority is set on the node level. So there is a node.set multiplayer authority, I think it's called, that you can change the authority from either the server, which I think is always peer 1, or any other remote peer. And by default, your objects are owned by the server. So if you, for your player objects and stuff, you'll want to set those, you have to set those manually. Authority is not synced by default here. The sync call here, you can make it either be called remotely, so it will not be called on the local peer, only the remote peers will call this, or you can make it so called local, so it'll run this function locally as well as on your remote players, and that's useful for when your server is also a player. So if you're a host, then you'll want to run your function as well. We have a transfer mode for reliability, so it can be unreliable, unreliable, but in order, and reliable. For the most part, you'll probably want to be sending things reliably, but if you're sending them very often, like for input commands, those will probably end up being unreliable or potentially unreliable ordered if the order that you're getting them in matters. And then there's transfer channel. I haven't actually used that yet, but technically you can make RPCs on different channels. If you're doing things like a chat or private chat, party chat, things like that, you can send these RPCs on different channels for that. So all RPCs you can call the multiplayer.get remote sender ID if you need to get who actually sent that RPC. And here's examples here in GDScript, also in C#. Here you'll see a couple of different RPC functions. So you can call RPC ID, which will let you send to specific peers. So peer number 1 is always your server or the host of the network. And if you wanted to send an RPC directly to another client, you would have their peer ID, which you can get from, there is a get unique peer ID you can get from anyone's network connection, which we'll look into the events that get fired off in just a second. When other clients join, you'll get their peer ID. Channels, and this is a small lobby. Don't need to, well, I guess we do a little bit. There are 3 events that get fired off. So in GDScript, you have signals. So you'll make a signal for player connected, player disconnected, or the server disconnected. What you have built in here from the multiplayer API, we have a peer connected, peer disconnected, connected to server, connection failed, and server disconnected. And those will all get fired off automatically for you. In C#, you create a delegate with the signal attribute on it when you want to create your own signal. And if you want to subscribe to the different signals we just saw, they're just regular events that you can subscribe to here. You'll also want to not forget to unsubscribe to these as well in destroy. There is an automated leave tree callback that you can unsubscribe for your events from. And let's see, yeah, that's really it for the actual lowdown on high-level API. We'll take a look at a little bit of what is happening here. So in all right. Let's talk about some of the other assets here. Didn't want to just do LAN multiplayer only. So there is a couple of different plugins here. One is called NetFox, and it has a C# implementation as well. So NetFox here handles more higher level functions. So this has client prediction and server reconciliation built into it, which is really cool, but a little bit beyond what we're going to go through here. These guys also made, showing up here, called No Ray. this we will use. And this is providing a self-hosted uh, punch through relay service here. So NoRay will first attempt a NAT punch through connection that will connect your host and your peer directly through IP address. If that fails for whatever reason, it will attempt to connect through a relay server. They have a demo server that they run you can connect through basically while you're in development. But once you actually go to production, you'll want to host your own NoRay relay server somewhere. Either self-host it or throw it up on Amazon or wherever for your players to connect to. They also have no hub, which is not actually on asset library, but you can pull it up from unfortunate SEO. So yeah, all their stuff is on GitHub as well. NoRay, NetFox, NoHub. NoHub is a lobby server list manager here. And it just works as a basic lobby service here where you can browse, connect, quick join, all that good stuff. It's pretty basic. You're not going to have matchmaking or anything like that. You could implement something pretty basic on top of this, or like basic like elo rankings or something like that. But for NoHub here, once you download the nohub.gd, you can throw that into your add-ons folder, and here is where all your add-ons show up. And from here, you can grab them and use them as you like. For NoRay, it is set up as an auto load here. Here in globals, auto load. Here. So the NoRay singleton, you can grab it from the remote scene when it plays. I'll show you how to do that in a second. But for NoHub, there is a NoHub client that you need to set up. It is not here as an auto load, but you can grab it from your scene. Grab it from your scene. This NoHub client here. You can open this in. Oh, I don't have that set up yet. So in your project, if you wanted to open this in Visual Studio, You can do that. That is in project settings. There's a .NET. Somewhere. Advanced settings. Oh, there it is. .NET project. Oh, where's the editor? All right, let's look and see. You can find that. Oh, editor settings, project settings. So for the external editor, we'll just use Visual Studio. Then open this. I have to reboot. The other thing is Godot does not automatically recompile your C sharp. You make changes, you have to go in and click rebuild project all the time. And I think this is the first time I'm building this on laptop. Coming up eventually. So while that's building here, in C# here, when you want to have your variables show up in the inspector, you just pop a export attribute there in front of it, and that will make sure that it shows up in the inspector. For our lobby relay, we also need this packet handshake node here that we're going to grab from our get node here whenever we start up. So just like in GD script, when in C# you just have this underscore ready override here that gets called whenever this node gets loaded for the first time. And here we are just creating a new EN multiplayer peer. As soon as we start up, we're going to grab our node here for NoRay. This is going to be in, since it's the auto load, it's just going to be right at root here. And this will get our NoRay node. We'll also do the same thing with packet handshake because it is, it's going to be here in our project settings. Globals. Here, packet handshake is part of NoRay. This is part of how it will do the NAT punch through when we try to connect to it. I think when I made this, I was using localhost, I think for I don't remember now. Here we can just script. C#. When I was at home, I was running these servers through localhost on a Docker instance, but I never set up port forwarding there at home. So we'll just connect to the regular one that he has set up here, which is Fox's Sake Studio. I think. Yeah. For NoRay, it's 8890. Studio. And the IP is should be all we need for the ID. It just needs to be unique to the servers here. I think this will work. So for our NoHub client, since it's not actually auto-loaded, we have to load it up ourselves. And it is what's called ref counted, which is basically how GDScript handles garbage collection. So we're just going to grab it from our add-ons. I'm actually not sure if this actually will work in a build or not. But we're just loading it from the add-ons directory. It'll work fine in the client, in the editor. And then NoRay has a number of additional events that it will call. So to connect to a signal or connect to a signal from GDScript, because our NoRay is technically GDScript here. I didn't feel like rewriting NoRay into C#. No reason for that. You just call your node GDScript.connect, and then you pass in the string for the signal name, and then you give it a callback, which is going to be your delegate here. So for the onConnect NAT, this will get fired off when it first tries to connect through NAT punch through. So it will give you the IP address of the other peer and the port that they're trying to listen for. Then it will try to connect to that. If that fails, it will roll back into onConnect relay, which will then give you the relay server address, and you just connect through that. We have on OID, so your NoRay, the relay server, will give out its OpenID address, which is what you'll use to connect through the relay. This is kind of the relay ID. This will be unique for each NoRay connection here. So yeah, once you do that, you'll need to register NoRay. So in our ready function here, we're just going to call this connect to host, which is connecting to the relay server. And to call a GDScript function, it's similar to the connect, but you just call your GDScript.call. You'll give it the string name of the address, of the function that you want to call, and then the parameters will come later. So this is just your comma-separated parameters that'll get passed into this connect to host, which we can look at. So this is just the GDScript for NoRay. Down in our tree. connect to host here. This is connecting to the no-ray servers. That probably should be renamed to something else, whatever. And disconnect from host. There's the register host. We don't have to worry about that. This was the no-ray server, which is your relay server. So that will be what is connecting over the internet. Right. No hub is going to be your lobby browser. So that will show up basically anytime you create a relay, you'll also create a no hub lobby. That way people can look and see what all lobbies are available. Back in our network manager here. So after we've registered, so every peer, even if you're just going to be a client, you'll need to register yourself with no-ray. So that way, no-ray knows that you exist, so it knows where to forward its packets to. Once you do all that, you are going to be creating a stream peer TCP, and then we're going to use that to connect to no hub. So stream peer TCP is basically just a regular TCP client. In C#, I think it is just called TCP client or something like that. And this will just connect to any random TCP IP address and port. I don't think I actually finished this. Once you create your host here, you will either start your host or start your client. Generally, you'll want to start a host first, so people will have something to connect to. These will be connected up to buttons. I actually have any buttons connected to this right now. Oh yeah. So what I did was basically we're just creating a just straight server here and starting our peer. At that point, you're kind of done with starting the host. For starting the client, you can just connect directly to that IP address if you're on the LAN. If you're on trying to connect through no-ray, you'll need to have a no-ray ID. That's that open ID number. Generally, you would get that from either your lobby or it can be shared through like Discord or whatever as just the ID that you want to connect to. So our on event. Yeah, so like yeah, there'll be like your standard like 6-digit code or whatever that you wanted to connect to. You could do it that way. A lot of games do it that way, especially the weird co-op friend slot games. You just type in your 6-digit code and go. Yeah, Jackbox, Peak, or Be There Yet. I think Repo does it that way too. I don't think they have server browsers. Yes. We can look at not check out an example here, which I think theirs is an example. First brawl. I don't think I have this downloaded here. This real quick. What? Okay, so this will be using more of the NetFox synchronizing components here. Still have more things like there's a rollback synchronizer, there's a rewindable action synchronizer for rolling back actions like shooting and things like that. Spawning effects can get rolled back with that. But what we want to look at here is going to be the no ray and no hub implementations, which I think are should be built into this one. Okay. And when you want to spin up a couple of editors here, there is how to do the tools, I believe it was. On instances. Two. Okay. Should just work. It might not work.
I was going to show you all kinds of cool executions. I was like,
Oh, let's try it on land, I guess. Jesus. That might be why. Same world. Yeah. Okay, so we are here saying, here we go. So, uh, so yeah, this is just connecting through localhost here. And yeah, the other thing is, I don't think the out of focus window updates as when it's in focus, so that makes it double hard to test this kind of thing. Yeah, yep, that is unfortunate, but it does technically work. And another dude here. Very sure health even does anything. What I wanted to look at is the so here in the brawler, call it, um, everything in Godot are scenes. So even your player object here is just a separate scene, but this is more like a prefab if you're from Unity, in that it's just an object with predefined nodes that you can spawn in and instantiate as you will. The multiplayer synchronizer here is what is going to be synchronizing various, is all set up in your various functions here will be what is synchronized through your stats here. So your brawler controller, which is just your player controller, has variables, your spawn point, respawn time, jump speed, all of that stuff. The synchronizer is what's going to be synchronizing some of these variables. I think they're using the rollback synchronizer, which this will, yeah, I guess this has your actual, what is actually being synced here. So here in your states, you have your transform, velocity, speed, mass, and weapon last fired. So when you last fired your weapon, these will be synced up, and during the rollback phase, this will get rolled back to however many ticks happened during the last update. So if we were on a high ping environment, this might roll back 150 milliseconds and then resynchronize and resimulate up until the current. Same for the inputs. We are just syncing the movement, which is our WASD, our aim, which is our mouse position, and is firing, is just whether you clicked your mouse or not. This has here in the rollback synchronizer, this is your schema. So this is what will be actually sent out every tick to the server or the host. We have our process delta, which is just our update function every update. And we have here is where this magic happens. There is a rollback tick that will roll back to a specific tick number, and it refreshes itself as it resimulates back up to client. So the first time you get a tick, it will be fresh. You might want to do things like spawn effects or bullets or explosions, like we're doing here. The first time we do this, it will respawn itself. There's also, you add your displacement, so that's how you are moving. If you get hit by an explosion or whatnot, this is what will calculate all of that. Sometimes you might want to skip predicting. So if you are on like your player character, you don't want to be rollback predicting on your own character. Since you're already up to date as the client, you want to ignore predicting for yourself. But other players, you want that to happen. You still have to apply your gravity and all of that good stuff, your movement in the rollback tick. And then the other two functions are respawning and if you're on the floor. I think there was some bug that you needed to force to be on the floor while rollback is happening. I think that's the reason why this is there. And I haven't looked into the rollback action yet. Um, but yeah, that's kind of it. There's not a whole lot actually going on with the networking in Godot. You basically are running everything locally until you send your inputs or updates through an RPC or through a synchronizer. I'm more used to Unity where there's a network manager managing things and network transforms and animators and all that good stuff. Uh, you could say they're missing, which is why things like NetFox kind of adds all that stuff back for you. Um, but for a lot of games, especially Godot, is kind of a 2D first engine. So a lot of things with like physics and whatnot and 3D stuff is kind of just an afterthought. So things like card games, like the biggest game right now is the Slay the Spire 2. You don't need all of this stuff for that. You just need to send what card you're playing where, and that's just a simple RPC. It'll just work for you. You probably could run a pretty decent one on like a Raspberry Pi. Your limit is going to be your personal network if you're running it from home. Um, you can only have so many ports open, and I think each instance there's like 1,000 ports can have open. So if you have more than 1,000 games going, you might run into problems just from pure networking. But the lobby itself, you don't need a whole lot. You are only basically hosting like an ID for the lobby and maybe like the number of clients that are connected to it. I don't think it auto updates. I want to say no hub. You have to actively pull it to get updates, so it doesn't actively push out every 30 seconds or whatever. So in that case, you would probably want to rate limit your clients. I don't know if that's actually in here. I don't remember seeing anything. Yeah, it's basically that's how this would work. Is that your client would just hit refresh and you it's basically a web request, and it will send back what query you ask it. Not really. I just kind of wanted to see what else was kind of out there, and it's kind of neat, but I am way too invested in Unity to fully switch over. But if anybody in the group wants to do a multiplayer thing in Godot, I can help out with it. Right. Yeah. Yeah, it was once it clicks, it's not as hard as you would think it would be. It's just a matter of managing who knows what and when, and knowing that your client might be running ahead of your server when you're doing rollback and stuff. So you'll want to keep that kind of thing in mind. Yeah, so it's about 7:30. I guess we can just wrap it up there. I'm not sure what we'll be doing next month. That will be, but I will keep everybody posted. See, I'll probably just end up going back into Unity and doing something. Um, Unity AI is going out of closed beta and into an open beta. So I might revisit that a little bit. That has actually changed a lot since we last looked at it a couple of months ago. Yeah, still recording.